Hello everyone, welcome back to rkphysicsshiksha. In the previous video, we have discussed about the same model of question which you are now seeing, which is where we have taken x is equal to at and y is equal to bt minus ct square. But I am here doing with the values now considered here, which I told in the previous video of the same type of question which I told is I have taken a in the place of 6 and b in the place of 8 and c in the place of 5. So for the same question now with the values we are going to do it, and we also will be calculating angle of projection, velocity of projection, maximum height, time of ascent, time of descent, time of flight, and range of the projectile the same way. See, we can use the same formulas as or otherwise you can just simply do the lengthy method. This means for calculation of each we can follow the same steps that we have done in the previous model of similar type of question with variables considered. Instead of constants here where the values of a and b c are given here, there they were not provided. Now we will use these values and calculate it. Before going to calculate any of this angle of projection or velocity of projection or maximum height or time of ascent, descent or flight of the projectile or the range of the projectile, first we should calculate, because we are provided with the displacement of the particle along x-axis and the displacement of the particle along y-axis, which are varying with time as x is equal to 60 and y is equal to 80 minus 5 b 5 sorry 80 minus 5 t square. These are the displacement provided, and in this case if it is a displacement provided, we have to calculate the velocities, we have to calculate the accelerations as well. So for that, first I have x value provided here. What is the x value I am provided with is here x is equal to, I am provided with 60, and similar way vertical displacement y is equal to 80 minus 5 t square is what we are given here. So now differentiating this with respect to time t, what I'll get here is dx by dt is equal to 6, because d by dt of dx by dt is equal to d by dt of 60, where d by dx of d by dt of t is 1, so that means it will become 6. That means velocity along x-axis is constant, which is equal to 6 meter per second. Similarly, if I differentiate this equation with respect to time t, what I get here is I get dy by dt, which is equal to d by dt of 80 minus 5t square, because rate of change of displacement is equal to velocity. Here also rate of change of displacement is equal to velocity, so that means I get it as vy, rate of change of displacement along y-axis, I take it as vy, from which d by dt of, I can write it as 8t minus d by dt of 5t square. So from which I write vy is equal to d by dt of 8t is 8, because d by dt of t is 1, minus 5 is a constant here as 8 it is here. So that means what I get here is I get d by dt of t square. We know very clear formula, d by dx of x power n is equal to n into x to the power of n minus 1. So in that case 2 into t power 2 minus 1, I'll get it as 5 to the 10 t. So vy value is not constant. Vy is not constant, it is varying with time. We know that very clearly. Horizontal component of velocity always remains constant. Vertical component of velocity continuously will be changing with respect to time. Now, what will be the value of acceleration? Differentiate velocity with respect to time, you get acceleration. So, differentiating with respect to time t, the above equation, what I get is here acceleration is what I get. So ax is equal to dvx by dt, which is equal to d by dt of 6, which is a constant. So acceleration along x-axis is 0. This also we know very clearly, acceleration along x-axis is 0. Similarly, if I differentiate this equation with respect to time t, what I get is I get the y component of acceleration, which is dvy by dt is equal to d by dt of 8 minus 10t. Differentiation of 8, which is a constant, is 0, minus differentiation of 10t is 10 is a constant here, so d by dt of t is 1, so it will become 10. That means the y component of acceleration is minus 10 meter per second square. I have ay ax, I have vy vx, and I also have x and y values. Now I know all the values, we'll write them all once. So v, or else velocity vx is equal to, I have it as a constant velocity which is 6 meter per second, and vy is equal to, I have it as a variable which is varying with time, which is 10t meter per second, and I have acceleration ax is equal to 0, and I have acceleration ay is equal to minus 10 meter per second square, which is constant, again. Now if we are supposed to calculate, first thing they're asking you to calculate is angle of projection. Angle of projection, if I am supposed to calculate, if you remember, we have drawn the diagram in the previous video also. Now also I am drawing it. If you take a projectile here, the projectile is projected like this. If you have a projectile considered, and if the initial velocity is in this direction, initial velocity of projection is u here. So if I have to consider the components of initial velocity, I'll get if the angle is theta, I get vx along ux along x-axis and uy along y-axis. So that means if I take this uy vector here, which is here, this uy vector can be replaced because it is a vector quantity. Without changing its alignment, you can replace it to add it up by ux triangle of vector addition also. So I just take it as uy replaced here. So uy is here, and that means from which I can simply calculate the tan theta value as tan theta here, angle of projection is theta, so tan theta is equal to, I can write it as y component by x component of initial velocity. But what is the initial velocity equal to? Here if you observe, I have vx value as 6 meter per second, which remains constant at any instant of time. So initial velocity or velocity of projection with which the body is projected, which I take it as u, I can write it as u bar is equal to ux I cap plus uy j cap. This initial velocity is calculated at what time? At t is equal to 0 seconds. Whatever the velocity is there for the particle, that will be the initial velocity of the particle that is projected with an angle theta with the horizontal. In that case, I have velocity vx as a constant, which is 6 meter per second, because vx value is constant throughout the motion. Initially also it is 6 meter per second, finally also it will be 6 meter per second, because the horizontal component of velocity always remains constant, which we can take it as ux. Now what about uy? Uy is equal to vy at t is equal to 0 seconds. At t is equal to 0 seconds, because uy vy velocity at any instant of time t seconds, we got it as 8 minus 10t, but at t is equal to 0 seconds is what the initial velocity. So uy is equal to, if I substitute the 0 value in the equation, I get it as 8 meter per second. So I got uy value as 8 and ux value as 6. So the value of initial velocity will be u bar is equal to ux is 6 I cap plus 8 j cap meter per second, and magnitude also you can calculate, which is magnitude of initial velocity is equal to u, which is equal to root of 6 ux square plus uy square, because they are perpendicular to each other, the cos component, because you can use the formula like this. What is that? Ux square plus uy square plus 2ux uy cos theta. Theta between ux and uy is 90 degrees, cos 90. So in that case, our whole of this term becomes 0, which is nothing other than this formula is from where we get it from the parallelogram of vector addition itself. So u is equal to, I'll get it as ux is 6, that is 6 is 36 plus 8 8 is 64, which gives me initial velocity of projection is 36 plus 64 is 100, which is root of 100, which is equal to initial velocity of projection is 10 meter per second. The velocity with which the particle is projected is 10 meter per second. Velocity of projection we got now. Now they're asking you angle with which it is projected. So if I have to calculate the angle with which it is projected, I can calculate it very simple way, which is tan theta is equal to, from the right angle triangle here, you have it as uy by ux, as I already told you. So tan theta is equal to, what is ux here? So sorry, ui is 8 and ux is, we have it as 6. So you get it as a 6 by 8 by 6. You can even simplify it, whether you can write it as tan theta is equal to, I can take it as, if you divide it by 2, what I get it is, sorry, if you cancel it out, 2, I get 2 4s are 8, 2 3s are 6. So it will be 4 by 3. 4 by 3 means the theta value, if you are supposed to calculate, very simple. We know one triangle. If you remember, if you know this one, it will be easier also. Please remember this. If this is theta, if this will be a 5 and this will be opposite is 4 and adjacent is 3, because if you observe, tan theta will be always opposite by adjacent. This will be possible at what angle of projection, at what angle means it will be possible, right? For this right angle, for these values, it will be possible only if theta is equal to 53 degrees. This is one triangle for 53 degrees, and we have one more such a triangle also, you should remember, for 37 degrees. Only small change will happen here. I'll just tell you that also. So if you take a triangle, right angle triangle, if this theta is 37 degrees, that means hypotenuse will remain same, but the only thing that changes is these two values will change. For 37 opposite will be 3, for 53 opposite will be 4. That means by this triangle it is very clear that theta is equal to 53 degrees. Now we have the angle of projection also. What else are they asking you? They are asking you to calculate maximum height of the projectile. So we know very clearly maximum height of the projectile, maximum height. How to calculate it? H is equal to, you have it as u square sine square theta by 2g, or you can also write it as u sine theta is the component of velocity, which is horizontal component of velocity. Sorry, uy, vertical component of velocity. That means I can even write it as uy square by 2g. So provided you take g value as, I think they have not given here. So you take and we will only consider that g is equal to 10 meter per second square. So that means in that case uy value, I know what is the uy value. We know the uy value as uy is 8 meter per second. That means I get it as 8 meter per second, means 8 8 is 64 divided by 2 into 10. So that means the height it is attained is 64 by 20 is what I'll get. 64 by 20 meters. If you want, you can simplify it also further. And what else we are supposed to calculate? Time of flight also we can calculate. Time of flight, which is capital T, is equal to, we have it as 2u sin theta by g, or you can write it as T is equal to 2 into u y by g, from which I can write T is equal to 2 into uy is 8. So it will become 2 into 8 is 16 by 10 seconds. This is the time of flight. If you want to calculate time of ascent, time of descent, it is very simple. Where is time of ascent and time of descent? What will be that equal to? Time of ascent will be equal to time of descent, which will be equal to time of flight by 2, which is 16 by 10 into 2, which will be equal to 8 by 10 seconds. This will be the time of flight. Sorry, time of ascent or time of descent. Next thing is range of the projectile. Range of the projectile is always known to us. Range is equal to horizontal component of velocity into total time. That is, horizontal component of velocity is ux. Ux is ux value we got, which is constant, which is that ux we got here in this question is 6 meter per second. So if you have the ux value is 6 and time of flight is 16 by 10, which is the total time, that means I'll get it as r is equal to here, if you want you can cancel it also or keep it like that as well, no problem. So you get it as a 96 divided by 10, you can write it as. So this will be the answer. So what you can do is, in any such a model of question, if the values are provided, it will become very easier for us to simplify it, because instead of the constant, just the alphabetical values A, B or C, instead of that, if you get the values, it will go simple for mathematical calculations. So Such questions, if you get, not everything they'll ask you, only one of these values that we have calculated, they can ask you the initial velocity or the velocity of projection, or they can ask you the angle of projection, or they can ask you the time of ascent, time of descent, or time of flight, or they can also ask you the range of the projectile. For anything of such, in such a model of questions, this is the process and this is the way you have to solve it. Hope you understood the whole solution, and we will be coming up with the next video for the case where we are supposed to calculate the same values again: range of the projectile, maximum height of the projectile, velocity of the projectile at the point where the particle strikes the ground. For the case when you project an object up the inclined plane, and next video will be, after that it will be down the inclined plane. So for more updates on every single videos of this type, what you just do is, please do like, share, comment and subscribe our channel. Thank you.